Good morning, everybody. So I want to talk to you about the history, really, of evolutionary architecture, because over the last couple of years, this notion of evolutionary architecture has been getting slightly less dangerous to discuss. And when we think about how things have gone with Agile, at the beginning, Agile was the dirty word. And then it expanded out, and then it was okay for developers, and then it was okay for analysts. And then it took a while for testers to realize that they didn't have to test the entire application or wait until it was all done. And we've been slowly expanding out the roles of people who are comfortable doing Agile. And we're getting to the point where architecture is now coming into that sphere, that people are starting to feel comfortable with the notion that perhaps you don't have to specify all of your architecture completely up front, that we can do some of these things iteratively. So I want to start by talking about how this really is grounded in the Agile Manifesto. And if you go back to the principles, there are several principles that apply. And if you look at a traditional enterprise architect role, very often they feel their responsibility is to define a technical direction and understand how the company is going to work together and such. And this all has to be done up front, and it's very prescriptive. But when we look at the manifesto, we see things like how good architectures actually emerge from self-empowered teams. And there's a focus on simplicity. And there's also this focus on being able to respond to changing requirements. And unfortunately, there are a lot of enterprise architects, and I've talked to a lot of them, and very often they'll have these pesky little things in their performance criteria that they're judged in part on their ability to have code be reused, which means even though they're potentially disconnected from what's going on in the actual development teams, they have to somehow figure out with their magic crystal ball just what people are going to need so that they can get all this wonderful reuse that they keep talking about. And so that isn't necessarily set up to succeed. And what we're trying to do when we start talking about evolutionary architecture is rather than focus on being able to predict the future, we want to be ready for the future. So when we started this whole Agile journey, one of the major things that made this safe was the use of continuous integration, and how that allowed you to actually, rather than sitting back and trying to figure out what your code should look like, you could iteratively develop it, and the design would actually emerge from this process of adding something new, doing the next best thing, the next most important thing that wasn't yet reflected in the code, whether it was test-driven development or not. But this whole notion of this continuous integration safety net allowed us to protect ourselves from any mistakes that we might introduce. And so this was really the first form of emergence when we looked at how code bases were now being developed. And then we move on to thinking about patterns in a different way. Initially, patterns were very low-level code fragments, but then there were two books that came out talking about enterprise application architecture patterns and enterprise integration patterns. And we started to think about this pattern language at a higher level than we had before, at this architectural level. And I know architecture is this, very poorly defined word. Sometimes it's just whatever a company thinks is hardest to change, or whatever a company thinks it's the most important problem. And I actually prefer that second definition, because the role of an architect in different kinds of organizations is very different, and what they need to focus on is very different. But when we think about how patterns started to evolve, and now we're not just thinking about code patterns, but we're thinking about architecture patterns. And then we can start to think about how we might evolve architectures towards a pattern, just like we looked at refactoring code as a way to get to a particular pattern. I think one of the more significant intellectual achievements when we talk about evolutionary architecture is actually this notion of refactoring databases. As I said, it took a while for different roles to get comfortable with doing things in an iterative fashion. Oh, well, it's all right for the developers to do their code that way, but I need to map out the story in advance. And one of the most common areas that was really difficult for people to get their head around what does it mean to be iterative is the DBAs, the database community. Because when you think about how a relational database works, there are all kinds of performance issues that come in when you make potentially minor changes to the database. And they felt quite strongly that, okay, well, maybe we don't have to do the code all in advance, but I need to know what my whole data model is going to look like so that I can properly set this up. And we all know that even though conceptually data migration shouldn't be hard, data migrations are a mess. And as soon as you've got something in production in a database, if you're going to change that database, you've got to do a migration. And those things never go as smoothly as they should. I don't know why, but they're always just harder. And they get harder the older the data is, or the more active the data is. And so thinking about how you can actually evolve the database was a big issue. And what this book on refactoring databases, put together by Pramod Sadalog and Scott Ambler, they looked at how could we actually take all of these even large-scale changes to a database and put them into smaller refactorings and compose those refactorings together. And most importantly, include along with those refactorings the data migration for just that small change. And how does that help? If data migrations are messy, aren't they still going to be messy? Yes, but just like continuous integration tells us very quickly when we've broken something. And so we've got a relatively small set of changes to look at when something is broken. This refactoring approach to database migrations allows us to pinpoint which one of those isolated changes it was that broke the migration. So it's easier to fix. It doesn't take the problem away. There are no silver bullets. Really, there aren't. Instead, it makes it easier to fix by isolating the problem. And so database structure and your data architecture, which has always been a critical part of the overall architecture of a system, now became much more amenable to an evolutionary approach. Because you were no longer taking these huge risks on migrations, you could test these migrations in smaller chunks. And then, of course, came SOA. And service-oriented architecture is really a very, unfortunately, maligned term, and unfortunately, it deserves most of that. Because it was really a good idea at the time, and we just let it go so horribly wrong. Because what the vision of service-oriented architecture was is that you could change your business processes. You could change your flows. And we've been trying this for years with business process modeling languages and lovely little doodleware where your business executive can sit there and drag things around and magically the system changes itself to reflect whatever it is that he put on the screen. So we've been trying for years to figure out how can we encapsulate these pieces of business functionality to make it easier for us to effectively re-architect the system. And SOA was one attempt for this. And then you had the debates between the SOAP world and the REST world, and which one was actually easier to work with. And SOAP is actually, in some ways, easier to think of from the perspective of configuration and code generation and such, whereas REST is often thought of as being a bit more evolutionary. One of the distinctions that we draw between SOAP and REST is very often this distinction between orchestration and choreography. And what is that distinction? Well, the conductor of an orchestra stands in front of the orchestra, and everybody follows along. You have one single point of control, and that conductor does not like it if you do not pay attention to what he's telling you. And there's actually a piece that has two very different strands to it, and when that piece is performed by orchestras, they have two conductors. You've got one standing over on this side doing the one strand, and another conductor taking the rest of the orchestra through the other. That's what it means for orchestration. Choreography is much more like a dance performance. The choreographer lays out their vision. The individual participants understand what their role is and how they're supposed to interact at any given point in time and what the vision is. But you don't have a central source of control. All of these different actors, performers, are independently making progress. So I think given that description, you can see why REST is potentially a bit more evolutionary. And we're seeing more and more traction around REST-based architectures. And then perhaps even as significant as refactoring databases is the recent introduction of continuous delivery. And what continuous delivery really gives us is the ability to safely change. And just like continuous integration protected us from this more iterative style of development, where we could gradually introduce code without a huge plan in advance, because the continuous integration and the test suite that we had underlying it was our safety net for changes. Continuous delivery takes this from just the code level to the path to production, where we can now safely know that when we deliver software, that it's going to install properly, that the system is going to work. And we get to now focus, rather than celebrating that we didn't crash anything when we put out the new release, we get to celebrate the new features. Isn't that fantastic? That we can actually focus instead on what it is that we're delivering of value, rather than just being grateful that we haven't messed anything up. And so continuous delivery, by automating all of these different steps and setups, it allows us to be more iterative with our architecture. We can change things safely because we know all the environments look the same. We know that when we're going to put something in production, we know what that environment is going to look like because we ran the script. And we don't have to rely on some poor soul actually getting all the keystrokes right at 3 o'clock in the morning. So continuous delivery is a major enabler. And since the advent both of cloud and continuous delivery, we're starting to see, again, a lot of innovation in architecture, including things like microservices, which I'm sure you'll be hearing about here at this conference. So when we think about evolutionary architecture, then, what I want you to focus on is not so much what the architecture looks like, but what principles you want that architecture to display. I don't want to focus so much on maintainability. I want to focus on evolvability as a first-class citizen. I want to think about the organizational implications of my architecture and take into account Conway's Law, which is starting to actually come up quite frequently in discussions I have with architects. We want to think about communication patterns. We want to think about testability, and one of the things that we found is if you focus on the testability of your architecture, you will come up with a cleaner architecture than if you don't pay attention to it. So testability is also important. And so these are the principles of evolutionary architecture. You want to be able to establish what you want your architecture to look like, what you want it to evolve to, and that's why it's evolutionary architecture and not emergent architecture, because we have a goal. We know what good looks like, and we're going to continue to move the system forward until it reaches that goal state, which of course it won't, because the goal will change. That's the IT industry. So evolutionary architecture is actually no longer this dirty word, for which I'm very grateful, because I actually spend a lot of time talking about evolutionary architecture. So thank you very much. I hope you enjoy the conference.